Meow 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 meow.
Hello and welcome to a video. In this episode of the Super Circuit Bending Super Show, we are going to talk about the setup phase of a process. I'm going to define what that means, since as far as I know, that's a term that I just made up. I'm also going to go through 3 different approaches that I've seen other folks take. There's obviously a million different ways to approach this stuff, but I think it broadly falls into 3 different categories, and we'll talk about what each of those are, and you can decide for yourself what works best for you. Then in typical Super Circuit Bending Super Show fashion, I am going to go through every step of my personal process in real time as we go through and continue working on our Yamaha REX50 that we kicked off in part 1 of this episode. So some minor housekeeping before we dive in. For those of you who aren't familiar, the Super Circuit Bending Super Show is a series where I show the full process of circuit bending projects and talk a lot about the theory or practice behind what I'm doing as I do it, and I also make sure to show as much as possible in real time. Now the reason for that is I always felt that there was a really large barrier to entry getting into circuit bending, which is very odd since it's a very kind of punk rock DIY sort of endeavor. So it didn't make a tremendous amount of sense to me that it was this hard to get into. So I'm hoping that by showing the full process and making these videos, it can kind of demystify things a bit and make it a little bit easier for folks just getting into it, as well as folks who've been in it for a while to think on some fresh ideas, and hopefully as this series goes on, build up a decent community of folks who are comfortable sharing what they work on and sharing their expertise and experience with the rest of us. So what is setup, and what do I mean when I say that? Like I say, as far as I know, I made that up. I'm sure there's a better term that folks use. I'd be curious to know if anyone has a better one. Definitely leave a comment below. I'd love to hear it and steal it from you, frankly. But when I say the word setup, what do I mean? Basically, I'm talking about the part in the project where we figured out what we're going to do to this thing by exploring its guts, drawing up various bend points, deciding on the values of our various controls. But now what? So the next piece is more of a design phase where we think about where are we going to mount our controls, where are we going to mount, in this case we have a patch bay, so how are we going to go about creating that patch bay? And there's a lot of factors that go into this decision-making process. But essentially I'm referring to that whole phase in a project where you're getting ready to actually circuit bend as the setup phase. The way I think about it, there are basically 3 very broad approaches that one can take towards setup. The first one is what I like to think of as the traditional approach. I think this is what a lot of people think of when they think of circuit bending, and that is essentially where you plan out what you're going to do, and then you grab a drill, start drilling holes, grab a set of markers or paint markers. When you need to draw on your labels, you just draw them on there, and that's it. You just go for it in that sort of approach. So just as a few examples of that, one really great example is Look Mum No Computer, especially any of his videos where he goes through the Cosmo builds, where if you're not familiar, he'll basically grab a metal panel, a can of spray paint, and a silver marker and just go to town on it and knock the whole thing out. And that is a pretty typical indicative approach of kind of this traditional way of doing circuit bending setup, I think. The other person I want to mention here is not really a circuit bender. I guess she's more of what you would call a traditional maker, if there is such a thing. And that's Laura Comp. She does some really amazing design and hand lettering in her metalworking videos. And while it's not strictly circuit bending, I think that sort of style fits in very neatly with this approach and just shows that you can have a really artistic and defined style even when taking this traditional approach, right? It doesn't have to be quick and dirty and ugly looking. If you're actually good at art and know what you're doing, you can do that in really cool and stylish ways. And I think she's a great example of that. But typically I stay away from this just because I'm not a great visual artist. I only know how to draw one thing, and that's the cat logo I use for everything, because it's the only thing I can draw. And my handwriting is absolutely terrible. If you've seen my other videos, you know, and actually you can even see right here. This is what my handwriting looks like, and this is fine for me, but it's not great, especially when working on a unit like this, which I intend to sell when it's completely done. I want it to be legible for other folks and not just for me. So the upside of the traditional approach, as I've dubbed it, is that it's very fast, it's very intuitive, and very expressive. I'm a big proponent of the fact that circuit bending is more of an art than it is a science. And I think the traditional approach to the setup phase is where that really shines. Now, the downside of the traditional approach is that it does require a lot of artistic skills. And as I mentioned, I'm not very artistically talented when it comes to visual arts. Things like lettering, drawing, I am awful at. So this approach is not for me, but it is maybe the most common, and I think it's a fantastic approach to take, if I'm being honest. The second style is much harder to define, and that's what I would describe as an intuitive style. I would define that as devices where you don't have a tremendous amount of labeling. It's all about the placement of control and visual indicators of what that control does and making things intuitive. So within intuitive style, you would see a lot more controls like light-dependent resistor controls, where you can use your hand or external flashlights to change things. You might also see a lot of body contacts used in that style, whereas versus having something labeled, you just have a drawer pull knob drilled on the top of something, and when you intuitively go touch that brass knob that's sticking out of the top of the device, it does something wacky. So that style is very low on labeling, but very big on kind of intuitive and tactile design. I think the best example of this is Folk Tech. Hands down, their Omnichord design is probably their most famous thing that I've seen, and I say it's no labels, nothing like that, but it's gorgeous, and it kind of invites you to interact with the device exactly, not necessarily the way you should interact with it, because there's no such thing, but it really invites you to explore all the various bends, and there's a heavy emphasis, I feel like, on play and experimentation in that style. Then finally, there's what I call the assisted style. I need to come up with a better name for that one, because that sounds like, I don't know, assisted living or something. And that's not what I mean by that. So if you've got a better name for it, please leave one in the comments. But this is the style that I use. And the reason I call it assisted is because I have very terrible artistic skills. I also have a goofy hand, which makes it really challenging to do a lot of kind of artsy crafty stuff, even what I used to be able to do. In the assisted style, there's a much bigger focus on things like CNC, computer design, printing, 3D printing, and regular printing. So for example, in a lot of projects, I use 3D prints in order to create panels and labels, and that way I can get a good clean look that I could never do freehand, just because that's not really within my skill set. So when it comes time to need to label things or add lettering, a lot of times I'll either design panels in a 3D printed fashion that has labeling built in to that three-dimensional surface that I create, or on other occasions I will just print off decals that I can use. You can get some pretty great just inkjet printer transfer decals, and once you hit them with a coat of shellac or something to protect them, they're pretty much permanent. And that way you can use Photoshop or whatever kind of visual creation program you prefer to create your labels and decor and then apply them to pretty much any surface. That stuff's great because it works on anything. The downside of this style is that it requires a lot more equipment and gear, and the whole punk rock approach to circuit bending I think is really appealing, and this style, I don't want to say it flies in the face of that, but it definitely doesn't feel like it's in that spirit nearly as much as the traditional style, since it's a lot more sitting in front of a computer, creating 3D models or making design mock-ups and then printing them in the correct scale. And it's a little less approachable because you do need some of that equipment. That said, these days 3D printers are extremely cheap if you get I forget the names of the different kinds, but basically the traditional kind of 3D printer that moves around and prints things in layers by extruding plastic filament. Those are incredibly cheap. And the one that I have is actually a very cheap 3D printer, an old Ender 3 Pro. I think when I bought it new, it was like $200. And if you find a used one in your area, you can get 3D printers very cheap. I recognize I live in an odd area of the country, being in the Bay Area in California. My Facebook Marketplace has tons of $50 3D printers, and I realize that's not the case everywhere. That said, 3D printers are a lot more approachable and affordable than they used to be. So that is a viable option for anyone who's kind of in a similar space to where I am. And why I ended up picking one up is they're a great tool to use when it comes to this setup phase and opens a lot of doors. In addition to 3D printing, there's also just regular printing. Decal paper is a little on the expensive side, but at the end of the day, it's not terribly expensive to have an inkjet printer and some of those printable transfers. I think that's an especially approachable way to use that, what I'm calling assisted style. Now, of course, everything, and when I say everything, I mean nothing really cleanly falls into any one of those categories, right? So they're just made up terms that I feel like are useful when talking about this phase in the process to think, what kind of approach do I want to take? I think thinking of those 3 different approaches is useful. You may not, but don't feel like that these are really strict or rigid terms. I think pretty much everyone would fall into some combination of these, but there are some folks out there whose approaches are very much hybrid, and their whole style is very rooted in using those things. The person who jumps to mind is OK House Cat. So his designs are a really cool blend of what I refer to as the traditional style as well as the assisted style, where there is some technological processing, but also a big blend of that more traditional freehand approach. And it's a style that works really well for him and looks fantastic. So all that to say, that's just a way of thinking about different approaches for what I very broadly call setup. But let's get back to the specifics of our REX50. As I've had up on the screen here, what you can see on here is my very rough mock-up, which is usually my first step in the setup process. Typically, I'll sketch this out on a piece of paper, or if it's something like this unit where the front panel comes off really easily and it's something that I can just tote around and work with, I'll stick pieces of masking tape or painter's tape on it and just draw right on it with markers. That way I don't have to worry about the various dimensions if I'm trying to draw this out on paper. I can just intuitively feel it out. So from part 1 of this episode, we decided that we were going to have a 14-point patch bay, a clock mod, and an LFO. So I jotted down a list of the various controls I would need, and then just started drawing that out really roughly. If you can't tell just by looking, none of this is like measured or spaced out. But each of these dots would be an RCA jack for our 14-point patch bay. So there'd be 2 rows here of 7 RCA jacks each. I have these two RCA jacks labeled specially for our loop and ground pins. Since those were cool, really unique features, I'm going to use different color RCA jacks to set those two apart. And I thought stacking them right next to each other will also kind of indicate, hey, these are your normal glitch pins, but these two have a little bit of a specific function. Just to the right, we've got our patchable controls, and this is A, I did it wrong, and B, it's a little incomprehensible to begin with, because it's just my own shorthand. But basically the idea is there will be a switch here. One RCA jack will connect to the common point of that switch, and it will connect using a diode. That way it's a one-way street connection. And then the other two switch contacts will have their own RCA jacks above and below. And that way when you toggle the switch, it will make a connection from whatever point is selected here to either one of these points. And because it uses a diode, that's going to be a one-way connection. So not only will this let you kind of preset some things, it will allow you to make some more controlled patches where you're only sending the signals in one direction. Here we're going to have a control potentiometer. I talked about this a little bit in part 1, but the concept here is there's a low value 1K potentiometer here that you can patch into the points of, and as you turn the potentiometer, that will change the resistance between the patch bay points that you plug into it. So that way, instead of just making a hard connection between any of these points, you can put a little bit of resistance to them and get a little bit of control over those as well. I decided that lower here on the sloped portion of the panel, that's where I'm going to mount the controls for our mods. I thought it would be kind of instinctive to have patch-based stuff up here, mod stuff here. So here we'll have a potentiometer. This is for the rate control for the LFO, followed up by the depth control for the LFO. Then this kind of box with a circle in it is a switch. This is going to control the waveform. So this will be a 3-position switch that toggles between the triangle saw and reverse saw waves that we're going to use. Next, we have an indicator LED that will show us what the LFO is doing by having a visual that we can look at and see it pulsing. If you saw the first episode where I circuit bent the Meowsic, we used the eyes of that keyboard to serve the same function. Since this unit's a little more muted, I'm just going to go with a straightforward dedicated indicator LED. And finally, for the LFO, we're also going to have 2 RCA patch points. Much like the potentiometer that we have up here, this control will let us patch 2 points in, and then instead of manually controlling the resistance between the two, the LFO will actually alter the resistance in whatever pattern we've selected. So that way, you can kind of set up something that will change and warp over time even when you're not actively touching it. We can use the LFO to modulate our patches. Then finally, we're going to have our clock mod, and this we're going to set up pretty much exactly the same way we did on the Meowsic in episode 1. So we're going to have a switch to swap between LFO control or manual control of the clock. We're going to have a switch that is essentially the master control, which says, are we going to use the modded clock or the internal clock? That way we can just turn it off entirely and use the unit as stock if we want to. And then finally we're going to have a potentiometer for our manual control. That way we can kind of manually control where the pitch and clock sits. Now the first part of what we're going to do next is admittedly a little bit boring. So what I've decided to do for this unit is I'm going to 3D print 2 different panels. We're going to print an upper panel and a lower panel for where these tape blocks are. The reason I'm printing it in 2 parts is because trying to do the math to figure out this angle and then 3D print that angle correctly to make one piece seems like a huge amount of effort for very little payoff. So I'm just going to stick with 2 separate panels. So the first thing we're going to do is we are going to measure the width and height of each of these panel elements. So we'll start with the top one. And that appears to be dead on 41 millimeters. So I'm going to jot that down. Next up, I'm going to measure the width. Now, since this, I'm not trying to fit to the pre-existing panel, I'm just making it as wide as I want. I'm just going to use my roughed out approximation here to get a rough idea of how much space I'll need. I think 130 millimeters looks great. And I'm putting a star next to that measurement to indicate that that is flexible. So when I sit down to start to design this panel, if I go, oh geez, it sure would be great if I could make this 135 millimeters, I'll know that I can do that. It's totally fine. Next up, we have our lower portion of the panel. Looks like that's going to be right about 52 millimeters. That was tricky to get a read on, so sometimes you just kind of have to get what measurements you can and then kind of center them out. Next, I'm going to measure the width of this panel. And what I don't want to do here is I don't want to cover this label. I'm going to peel this back a bit. Actually, this piece of tape isn't doing anything, so I'm just going to remove it. And it looks like 115 millimeters. Should be good, but that is a flexible value as well. I'm just going to jot that down. So for the next part, we're going to take some measurements to see how large the radius for some of these controls are. And you would think I had this memorized by now, but I do not. So I'm just going to measure those real quickly. So for the pot, we're going to make a 7 millimeter hole. The exact measurement on these, I think, is 6 millimeters, but there's some tolerance. So this one measures about 6.6. So making a 7 millimeter hole should give us plenty of clearance so that it actually fits through. For the switch, we'll do 6 millimeters. Again, to give ourselves some clearance. And finally, I've got this RCA jack mounted in a little project panel. That is pretty much the same as the switch, so 6 millimeters. The last one I forgot is the LED, just because I don't recall what size the little lamp holders I use are. I don't have one of those handy, so I'm going to take that measurement off camera. I just wanted to show this process so you get the idea. I don't think anyone will be terribly bummed to miss me using calipers to measure an LED holder. But on that note, calipers are a fantastic tool for this. I just have cheapo Harbor Freight ones that are only a few bucks. You don't need crazy high quality machinist ones if you're on a budget. At least not for circuit bending stuff. Yes, what we're going to do next, we're going to take these measurements and actually design our panels. So I'm going to try to set up a screen recording and take you all through that process as I do it. So I'm just going to start voicing over this sped up clip of me working in Blender because, candidly, you don't want to watch a Blender tutorial by me, and I'm not really interested in making one either, so that works out. But basically I'll talk through what I'm doing on screen, not an in-depth how-to or anything. But basically in Blender I know how to do two things, which is make simple shapes and apply modifiers to those simple shapes. So what I'm doing here is I've turned a cube into a panel using the measurements we took at the end of the previous section. And what I'm doing now is creating a bunch of cylinders that will eventually become, I think of them as punches, because we can apply a modifier that will essentially subtract any other objects that intersect with our panel. So I'm not going to leave those cylinders sticking out of the panel like that. Instead, I'm going to use them almost like drill bits or something to put holes in that panel by applying what's called a Boolean modifier. So this is the top panel, and here I'm just arranging the RCA jacks. As I mentioned before, I'm not super artistically talented or anything, so I don't use sculpting or anything like that. Instead, I'm setting the exact position of each of these objects using the object properties panel. So when you see me typing in all those little numbers in the upper right, that's what I'm doing, is just arranging the positions and sizes of the objects. So over on the right of the panel, I'm setting up our patchable controls. And again, just tinkering with the positions of those punches to see where I want those to sit. Then I decided I wanted to space out the RCA jacks a little bit more over in the patchable section, so getting those rearranged. And again, I'm just eyeballing the various positions and getting it set up so that it, I think, looks about right. Doing a little bit of math in my head to make sure I have appropriate clearances for what I'm going to be plugging in. And now adding in some text elements. One thing you'll notice is that everything comes in huge because Blender tries to do things in meters, I think, by default, and then I have to bring it down to a millimeter scale. So if you're curious as to why objects keep popping up huge and then I shrink them down tiny, that's what's going on there. So here I'm creating a label for our loop point. Next up for our ground point. And you'll notice with these, at first I was thinking I was going to print these so that the text actually was sticking up off the panel. Later I changed my mind and used these as punches as well. But at first you may see me setting these just sitting barely on the surface and trying to arrange them so that they would be sticking out rather than be used as a punch. And here I was just tinkering around with different ways I could brand this. I don't like to do a huge amount of branding. I try to keep it relatively subtle. So you'll see I don't end up using a lot of what I'm tinkering with here, but I wanted to leave it in just to show some of these things. Now what I'm doing is bringing in an SVG, and that's the easiest way I've found to, with my very simple Blender knowledge, to bring in any kind of artwork or something, is just to create an SVG. A lot of times I just use a PNG and use a converter online. So, for example, here I've taken my website favicon, turned it into an SVG using a free in-browser converter, and now I've dropped it in and scaled it. I don't ultimately end up using it on this panel, but I think it's a really interesting process that you can do this with completely free softwares. If you have designs you want to integrate and 3D print in a really clean way, you can bring them into your project pretty easily like that. Now just making sure I'm happy with the final placement of everything, doing some really minor tweaks to the positioning. And this is the process I mentioned earlier where I'm applying all of those booleans. So basically I'm telling that panel to create a cutout anywhere it intersects with the whatever objects I select. So I'm now selecting all those cylinders I created earlier for our RCA jacks and patchable controls. And as I go through them, you're seeing essentially those intersection points disappear and the holes be created. And again, just tweaking some positions. And now finally what I'm doing on this panel is adding another series of cylinders that will be the punch outs for our screw holes. Here I'm just using very small M3 screws. So I want to say, if memory serves, I set those to like a 2.7 millimeter radius, something like that, so that the self-tapping screws have something to bite into. But that will give us a way to secure this onto our panel. The primary way it's going to be connected is through using the actual hardware itself, the different jacks. But I do want screws along the edges just to keep the panel from lifting up or looking sloppy if there's a gap there. Now I'm going through that modifier process again to create the cutouts for the screw holes. And here having 8 screws is probably overkill, but again the main purpose of these is just to help keep the panel flush, so can't really overdo it with that. Next up, I'm creating a new panel and a new set of punches. And I'm not the best at organization in Blender, but I do try to create little, I believe they call them collections, so that I can keep my sets of punches and sets of panels or sets of, the thing I intend to print at the end, in this case panels. But keep those separate from each other and try to put appropriate labels on them. I'm not always the best at remembering to do that, but I try. It's one of those things, you know, when you're first learning a software, it seems like a waste of time, but the more often you come back to an old project and have to remember, what on earth was I doing with these layers and these different components, the more you learn to appreciate taking the time to label things properly. So what I'm doing here, I'm just duplicating a lot of the objects from the panel I already created, since I've got most of the sizes I need, and that way, rather than starting up those huge new objects, I've got something much closer to the scale I need, and then I can just tweak them. So this lower panel is a bit more interesting just because it has a lot of different sizes going on. So in the upper part, from left to right, we've got 2 potentiometers, then a switch, then an LED holder, and then 2 RCAs. And then on the bottom, we've got 2 different switches and a potentiometer. Now I'm bringing over that same conversion that I don't think how to say that properly. I've made a copy of that same SVG conversion that I was looking at earlier. And again, just to save myself some time, I'm copying and pasting over similar objects from the first panel rather than creating brand new ones. It's just a little bit quicker to edit text rather than start from scratch every time. So here I'm creating the labels for our waveform switch. Got triangle saw and reverse saw selections. And just tinkering with the positioning of those. Next up, labeling our switch that swaps between the internal clock as well as the modded clock. Go through the same process to label that switch. And there you can see I had started labeling the wrong switch at first, but got that corrected. I think that's what that pause there was, as I was referring back to the notes we created in part 1 of this video. And next up, I'm labeling the switch that swaps between LFO and manual control of the clock mod. And finally, just tinkering around a bit more with positions to make sure I'm happy with them. With potentiometers especially, like in this project where I'm planning on putting labels on the potentiometers, I want to have as much room as possible, because the bigger the knob I can create for that potentiometer, the more room I have for creating those labels. So right now, or just then when I was tweaking those positions, it was with an eye to maximizing the amount of space I have for potentiometers. And now I'm creating those screw holes, same as we did before, pausing intermittently here to do some math and figure out where the positioning would be to get them even. On this panel, since it's not quite as wide, I just did 6. I think is fine. And I believe it was about at this point that I changed my mind and decided to punch out the labels instead of having them sit on top of the panel and protrude outward. Now now I'm just going back through and applying all the modifiers to our lower panel. It's funny, in this section it looks like I'm pausing, but actually my computer is taking a very long time to create each one of these modifiers now that I've got one scene with dozens and dozens of modifiers across multiple objects. It does start to bog your computer down. I believe if you actually apply those modifiers, it's a bit more, what's the word I'm looking for, a bit more efficient. But I do appreciate the flexibility that you can actually leave them live, I guess is what I would call it, where you can actually move the original object and the modification will move along with it, since it hasn't been permanently applied to the secondary object. It's kind of an active connection. So even though you can tell it's making my computer run a bit ragged, it is, in my opinion, worth it for the flexibility because I'm still able to tinker around with all these different positions. And as I've mentioned before, I like to think of this as much more art than science, so the ability to tweak things around on a whim is very important to me. And since I can't draw myself, Blender tends to be a place where I do that for 3D printed components. And just getting the last few modifiers in there. Now I'm switching back to the upper panel, since I changed my mind about how I wanted the labels to work, since I wanted them to be punched through. I'm now creating those modifiers, and I changed up the position of the text labels as well, so that they would actually go through the panel rather than sitting on top of it. And after that, I just export it, and I am all done. Our panels are done printing, and now they are ready to be painted. But before I jump into that, let me just show how these came out. Now, if you happen to be a 3D printing nerd, a few notes on this. I've printed these in neutral ABS, which basically means there's no dye or any kind of pigment built into the filament itself. The other thing you may notice if you are familiar with 3D printing is I printed these panels with a lot of extra walls. So a wall means a solid plastic surface anywhere around a hole. So you can kind of see these little rings around each one of the holes are pretty wide, and they're wider than they would normally be. And the reason I've done that is if I need to hollow these out, or if the drill bit catches on these, it will be fine because there's just solid plastic all the way around. If it was a really thin wall, it could break into the surrounding plastic, which is more of a mesh instead of being solid, and that would potentially damage the panel. So all in all, I'm pretty pleased with how these came out. My game plan is I'm going to stick these, probably using just a bit of hot glue or something, to the front of the plastic panel. And then I'm going to use a drill bit to drill through these holes and effectively use this panel as the template. And then I will do any touch-up paint that needs doing at that point. But I figured that's easier than trying to drill the holes and then get them to line up exactly with this panel. Better just to mount this, then drill straight through it. I think any damage done to the paint by the drill bits will be covered up by the components that we mount through these holes. So let's get started painting. Now over here I do have an oil-based paint that I picked up the other day. If you aren't already aware, pretty much every hardware store has like an oops rack. What they do is when they try to color match something for someone, if they don't get it exactly right, it will go on a steep discount. So that's a great place to just look for interesting colors anytime you're in the hardware store. I thought this was a cool blue-green. I think it's going to match the very 80s vibe of the REX50 really nicely. The RCA jacks I'm going to use are primarily going to be blue and green, so that's going to look really nice with this, I think. The one thing I will note is usually I use acrylic paints, but this one is actually oil-based. And I think that's actually going to work really well for a 3D print because it tends to be a little thinner and run into all the little nooks and crannies. The one thing I'm concerned about is since this is printed in ABS, acetone, which is a common thinner, will actually melt this. So I'm pretty sure it will be safe, but I do want to paint some of this on a different print just to make sure nothing's gonna melt. So I have this, which was meant to be a battery holder. As you can tell, it didn't print very well. It's got all sorts of big cracks in it. So I think I can repair those cracks, but ultimately it would not be the end of the world if this thing got melted. So I'm going to try this paint on there first. And because I usually use acrylics, I don't have a lot of paint thinner around, which is one of the reasons I've set up paper here. And I'm going to be using disposable brushes and just some disposable chopsticks to stir things up. I realize that's not the most eco-friendly way to do things, but I don't often work with oil-based paint, so that seemed like the safest way just to prevent it getting everywhere and ending up with a big mess that I'm not really prepared to clean up. Okay, so far there doesn't appear to be anything unusual happening. It does spread around. Poking it with this to see if I felt any kind of give in the plastic. I think that is going to work out nicely. What I'm going to do for these panels, since trying to work with just one hand could be a little bit challenging, gonna roll up some tape on the back to see if that will hopefully help keep these in place. Obviously, I'm not going to be putting a tremendous amount of force on these, so it doesn't need a whole lot of grip or anything, but having a little something to hold it in place, I think, would be a big help. And just making sure I get the sides there. One thing I was not expecting was for it to close up these little gaps like that. I'm just going to use maybe this pair of tweezers. I think what I'm going to do is just let it dry and see if I can maybe just use like a sewing needle, something really small like that, maybe even an X-Acto knife to remove it once it's dry. It seems like trying to remove it now, it's just falling right back in and filling in wherever I clear it. As always, I'm not an expert on, well, honestly, most of the stuff that I do. I just do it anyway. So if anyone has any good tips to share with everyone on painting things like this, definitely leave a comment. I, for one, would love to learn how to be a little bit better at this. So next, we're going to leave this for a few hours to dry, and then we will hopefully get them fitted to the panel. Now, another thing I'm going to do off camera, because these are going to go directly on the plastic shell, and going through these panels plus the plastic shell plus the metal undershell, or whatever you want to call it, would end up being really thick, and actually way too thick for some of the controls. Pretty much all the controls, actually. Because of that, I'm going to be cutting away sections of the metal inside piece. And I was thinking about the best way to get a shot of me doing that. And I'm actually kind of terrified of cutting wheels, if I'm being honest. I have one for my rotary tool, but it scares the hell out of me. And I thought, trying to rig up a shot of a one-handed guy using power tools he's scared of is probably just not worth it. So I'm just going to verbally tell you all, I'm going to cut out the metal section about where these will be sitting. It obviously doesn't have to be super precise since the plastic shell is on top. Yeah, there are many better people than me who can tell you how to do that if you're interested in learning the process. So when I come back, hopefully this panel will be all done, and that metal piece will be cut away, and we'll be ready to start assembling the top panel. So I lied. There's actually one more thing I'm going to do before I come back with the completed panels. When I started trying to clear out some of these labels, let me zoom in to give you all a better look, but that's when I discovered what the problem was. I'm going to try not to go into too big of a 3D printing rabbit hole, because there's a million 3D printing YouTube channels, and honestly, most of them are way smarter than me at this stuff. But just to give some context for what I'm running into, the way that I 3D print, because I use ABS primarily, is I print things on a glass bed, which is like very perfectly smooth. And then to get things to stick to that bed, what I do is I coat the bed in a thin layer of ABS paste. Basically, I just melt down extra prints in acetone, paint it onto the glass bed. The acetone evaporates, leaving just a thin film of plastic. So what's happening here is on those very small letters, you can see it's not actually a hole all the way through the print, like it is with the holes we made for our controls. Because of that very thin layer of plastic, the paint is actually getting trapped inside those letters. So rather than sit there trying to manually remove tiny bits of plastic, I think I'm too lazy for that. So what I've decided to try is just to do a wash. Basically, we're going to take a darker shade of paint, thin it like a lot, and then brush it on here. And since it's incredibly thinned, it should sink into all the little gaps and holes. And then we should be able to wipe any excess off the top of the surface while leaving behind what has sunk in. So it's a technique you see in a lot of like model and prop building to weather things and make them look more realistic. But I think it's going to work here to create a contrast. And if I'm wrong, we can just paint right back over it. So for my wash, I'm actually going to use a water-based paint. Typically, water-based and oil-based don't mix, but I checked with the internet and they said that for doing a wash, acrylic was fine or even recommended. So we should be good. And here I've got another bargain bin paint sample. This one was only 50 cents. And this is a really interesting super dark blue. Basically, I just grabbed the darkest color I had. I think this is going to look better than if it was black, because it's still kind of in that blue color space. So we'll still get a nice dark contrast, but not necessarily going full black. So right here, I've just got a little old pot. I think it's an old baby food jar or something, with, as you can see, quite a bit of water. And let's say we're just going to make a very thin wash using this paint. A little bit more than that. So now I have it. I mean, it's basically the consistency of water. You can see it doesn't run off of this knife, it just drips off. I'm no expert on this, I'm not a visual artist, so if someone else has better advice on making washes, I'm all ears, but that's what I seem to recall from my days of building plastic models, at least. So I'm going to start this Bent by Poetaster label, since that one is the trickiest. And you'll notice I'm not really brushing so much as just blotting. So my goal isn't necessarily to paint, it's to force the wash down into all these nooks and crannies, so I can get a closer look and see. Again, not doing much of a brushing motion, more of a blotting, and just trying to get this really thin stuff down in there. And then I'm just going to take a paper towel and just wipe away. So as you can see, it takes it off the top, but leaves most of the liquid that we've forced down inside. And sometimes you do need to do a couple of washes for it to really take the color. Since we're not using a full super dark black, we may need to do a couple passes with these. That is a-okay. The cat, I think, is mostly okay, but for consistency's sake, and maybe to get just a little bit of extra contrast on him, go ahead and give him a pass. And the tricky thing to do here is, if memory serves, you always want to wipe, not dab. So if you start dabbing, then you can accidentally get down into those same nooks and crannies and pull out the wash that you actually want to leave behind. Now, in areas where I don't want any wash to stay, dabbing is actually exactly what I'm going to do. You can see that it's already much more legible than it was, just even adding that tiny bit of a darker contrast color. So what I'm going to do is let that dry. I may hit it with a second coat of the wash, and then spray these with a little bit of clear coat, and they will be ready to go. So I'm back with the REX50 after doing some work off camera. First thing I have done is gotten this metal shell carved out, so that way our controls only have to go through the outer shell and our printed panels. I've also got our panels here. And as you can see, the cutout areas, this is the first time I'm actually testing this, but I was pretty sure I'd gotten it. But yeah, as you can see, we shouldn't get any interference from this metal plate. So one thing did happen, and anyone who is smarter than me probably saw it coming a mile away. As I mentioned, I usually use acrylic-based paints, and I also mentioned after using the enamel-based paint and getting the wash done that I was going to go put clear coat on the panels. However, as you might guess, the clear coat that I have is acrylic. As you can see, the paint completely crinkled up, and it's hardened up and flattened out now, but all of these extremely smooth parts were actually bubbled up and completely separated from the plastic. So rather than trying to rescue these, I have just printed off 2 new panels. They're the exact same file. The only thing I changed is I printed these at a slightly higher resolution. I think the other one was at about 1.2 or 1.5 millimeters per layer, and this one is, or I'm sorry, 0.15 millimeters per layer, and this one's 0.1 millimeters per layer. It's about as low as my printer can go, honestly. But as you can see, that made the labels come out much cleaner. I did go ahead and give them a wash treatment as well, just to help clarify parts where it didn't quite go all the way through the panel. So the next thing we're going to do is just mount our panels onto the plastic shell. I think I'm going to secure this one first and then add in this one so that I can press these together. And I'm just going to toot my own horn. I'm proud of this. I did get the measurements right, so we can still see all the original labeling, and we should still have room for all of our controls as well. First thing I'm going to do is use a bit of tape to hold these down. Just a couple pieces of tape will be enough to hold that still while I put in a couple of screws. To be safe, I might put one more on here. There we go. That'll hopefully make sure I don't flex it in the other direction. So I have these really small self-tamping screws that have the flat head that goes flush with the panel. I think these are going to work really nicely for this project. And to make life easier, I am going to try to use a power drill to get them to self-tap. And hopefully that won't go terribly wrong and rip through everything. One thing I do try to avoid power tools whenever possible, because it's really easy with, especially plastics from the 80s. It's really easy to go too hard and mess something up. We're going to try to do this as controlled as possible. Double check, but I believe that should be in, but not completely torqued down. Right, so I believe that is one in. Next, I'll try to do one in the opposite corner to give us a good grab on this panel. And for those of you not familiar, you may have seen what I did there, which is just back the screw out and then kind of blow out all the little plastic chunks and then start in again. Sometimes with these self-tapping screws, there's basically like a little blade cut into the threads of the screw. And if that blade gets clogged up with plastic chunks, it can kind of stall out. So just backing it up and putting it back in again is usually the best way to fix that. May have done the same thing with this screw, or I may have just gone a little too hard with this screw and kind of blown it out. What I should probably be doing, and what I'm going to do for the rest of these, is go ahead and drill just very small pilot holes. You don't technically need to do that with self-tapping screws, but in this case I think it would be a smart move. I also just noticed I put this panel on upside down. You won't probably notice that a while ago, but I just noticed it, so I'm going to use this opportunity, since all the screws are evenly spaced. I'm going to go ahead and use this to drill pilot holes, and then we'll fix the orientation. And I just realized, I don't know if I mentioned it in this video. For those of you who may not be aware, the reason I'm doing this mostly one-handed and occasionally have this weird, shaky gloved hand show up is I had a stroke about a year ago, and that's a result of the stroke. So just as a heads up, that's what that's all about. Obviously, if you have two working hands, there are better techniques you might use to do something like this. So here, let's zoom in actually. This is a good example of self-tapping screws are great, but they can sometimes build up this little, I don't know what you want to call that, like a molehill or something around the hole. So that was actually keeping our panel from being flush. So my hope is that these pilot holes will clear out enough of the plastic that we don't get this buildup. But if we do, it's not the end of the world. All we have to do is take the panel off and then file these off. So I've just got a mini file here. I'm not gonna lie, I kind of expected that to mostly crumble off as soon as I hit it with the file, but it's actually pretty on there. Okay, good. What happened there is this one, sometimes with these small screws, they're not really intended to be used with power tools. So when you put that much torque on them, they really form to the bit that you're using. This guy. And so it became so hard to pull off, it actually yanked the panel, or yanked the screw out of the panel. So I was worried it had stripped all the threads, but I was actually able to get it to go back in manually. One thing I'm noticing is this panel is continuing to lift. You can see the panel's not flush with the plastic case. So odds are what I'm going to do is try to get both the panels in place with all the screws. Then I'm going to remove all the screws by hand, not using a power tool, and then reset them after cleaning up any plastic shards underneath. And all I've done while mounting this one is just to press it up against here to minimize the seam. It's always hard to tell how well it comes through on camera, but when using these self-tapping screws, doing them by hand, it actually takes a good amount of muscle to get them to bite. This one, I think, didn't actually get any kind of bite before. What I would do if I was being good and putting these in by hand the way I frankly should be, is I would use a bigger pilot hole. One of the reasons I use such a small pilot hole is because I knew I was, with this many screws, I was going to be too lazy to do it by hand, so I went ahead and used a smaller pilot hole. to these, where I really put some oomph on it, they actually get set down into the panel nicely, which is what I want to see. The risk being what I may have done there, which I can't tell if I actually went all the way through the panel or not. These 3D printed panels are not very thick, so that's the main worry. And that should have all of our holes at least. Next, I'm just going to remove all these screws by hand. You can see that one, I think it's got really overheated and kind of melted. As you can see, we've got quite a few of those raised protrusions that are keeping the panel from going flat. Yeah, since these actually kind of are melted in and pretty solid instead of being crumbly like I expected, I'm actually going to go ahead and break out the Dremel tool just to sand these flat. I'm not a Dremel expert. I'm not sure what you call these grindy guys, but I'm just going to use one of these at a relatively low RPM and just flatten these out. That cleans it up way faster than going by hand. But for any final ones where I got it really close, there's still a bit left. Just hit those by hand. While I'm doing that, for anyone who might be concerned about the fact that the number of blowouts I've had with these and self-tapping screws aren't exactly super heavy duty. Just a reminder that the function of these screws is basically to hold the panels flat so that the edges don't curl up or lift off of this and make it look nicer, basically. The actual hardware of the jacks and potentiometers and switches will be going through both layers, so the really strong mechanical connection holding the panels on is actually going to be coming from the hardware itself. These screws are, again, just to hold the edges down flush to the panel. So if you were so inclined, you could just use an adhesive instead of these screws, but I always like screws for the removability, is what I was about to say. I know it's not a word, but I'm going to stick with it. I like screws for the removability of them, so you can take the panels off. It's clear you can take the panels off. Why you'd want to, I don't know, but you can. Whereas with an adhesive, you know, they're a bit more destructive typically. Keeping an eye on my camera, it's starting to get really warm in here. I think we are in the last blast of summer, insofar as California actually has seasons. It really doesn't, but it is warmer than usual. As someone from the deep south, I am not used to not having air conditioning. That has been something to adapt to. Yeah, I think it's come up in many other videos before, but my camera definitely doesn't like it. It did not feel like this one was biting. It appears to be threading in. And if you're looking at these wondering why there's 8 screws up top but only 6 on the bottom, I just decided there would be. If I'm being perfectly honest, again, I probably could have gotten away with just doing 6 up top, but when I was eyeballing it, looking at the model, it just didn't look right to only have 3 on each row. This other one is also blown out, so put some glue in here. That screw just ends up being decorative. It'll at least hold the panel down. Now what I'm going to do next, because my camera is really unhappy with how warm it is, and I don't think it would be particularly exciting to watch, I'm going to go ahead and drill out these holes off camera. Before I do that, I am going to wait at least 30 minutes, maybe an hour, for the super glue I use to dry. So the last thing I want to do is accidentally apply some torsion and break that bond before it can properly form. So I will be good and patient and wait a bit. So I've got the panels installed on the REX50 and got all the holes for the controls drilled out. The only thing you really missed was something I wasn't expecting, even though I guess I probably really should have. So much like when we drove in the screw panels, as I was drilling the holes out, the plastic underneath was creating a gap under the panel. So I did remove the panels again, grind those away with the Dremel tool, same process as before. But just wanted to share that I had to do that additional step as well. But now we should be ready to go ahead and install all our controls. And I just noticed a loose piece I didn't clear out. There we go. Alright. So I'm going to start with the potentiometers. And as I've shared before, I always break these little tabs off. I think they're supposed to dig into, like, if you're using a wooden panel or something. They'll keep them from rotating, but in this case, we're just going to use the tension of the nut itself. Well, the other thing I forgot to mention, I thought that this soldering mat would protect my desk while I was drilling a bunch of holes, and it technically did. The desk is fine, but yeah, I accidentally drilled a bunch of holes in my soldering pad. So, whoops. So, as you can see, there's not a whole lot of clearance with these, which is why I had to cut out the metal panel underneath, just to make sure we had enough room to actually mount this stuff. And even so, it's going to be a pretty tight fit. Wow, that clearance is so snug, I don't actually even think I have room for a washer. But that will be fine. The plastic panel doesn't necessarily need a washer. So. As we go, I'm going to label these on the back. That will just make all our lives easier down the road. Right, next up is our 100K pot. This is our rate pot. Okay, that one is not wanting to bite. Take a look. Let's see if I can zoom in here. I think I can see why. As you can see, it's not quite flush right here. There's a little bit of a gap, but I think we can get away with that. I'm going to try to just use an X-Acto knife to clean this up a little bit. It looks like the one next to it was having a similar issue, so I'm going to clean that one out as well. And it's hard to tell with such tight clearances. It may be that itty bitty gap between the panel and the shell is actually what's causing that. Let's see if I can get a switch connected. So maybe if I can just get something connected, I can kind of squeeze the panel together with that. Okay, so we've got plenty of room for a switch. This is just a little 3D printed hex wrench, and this is great because it doesn't scratch up the paint the way a metal one would. Try to use these whenever I can. Let's see if by adding that on created enough tension. I can attach these. So it's barely there, but I did manage to get it. And what I was adjusting there, because I don't know if you got a good shot of it or not, but sometimes when you have to enlarge a hole like that, especially if you can't fit a washer, the nut tries to slip into the hole. So I was just trying to adjust it so that the nut is sitting flush on the panel rather than trying to dive down into the hole there. Now for our last pot. This is the 500K clock pot. Okay, there's a little bit of a lip on this one still. Those are on pretty loose. I'm going to go back through and tighten everything down. That's our final step. The reason I wanted to get that in really snug and just use hand tools if possible is now all the switches kind of sit at just the right height. Or pots, not switches. Whereas if I dug one out with the Dremel, I might sit a little bit higher than the others. Next up, I think it makes sense to do our other switch. Next up, this is just our on-off-on switch for the wave selector. And my wobbly hand is really going today, so keep throwing stuff. I don't know how visible that's going to be, but I'll try to label these. And hopefully I'll be able to read that later, and that way I won't have to flip the panel over to remember which wire goes where. And I need just one more on-off switch. I'll fine-tune the placement and tighten these down once everything's in. I think for the RCA jacks, I'm primarily going to go with green and blue for the color scheme on this one. So I think I'm going to use green on all the regular RCA jacks, and then use offset colors for different ones. And one of the reasons I love using RCA jacks for these is you can get a big bag like this for just a few bucks. They're much cheaper than banana jacks, which are the want to say standard because there's really not a standard, but I guess you might think of them as the more common way to do patch bays. I just realized I forgot to put in the LED holder. Get that attached real quick. This guy just screws on from the back. As you saw, this is a lot of RCA jacks to mount, so I'm not going to make y'all sit here and watch me screw those in while I'm shaking around everywhere. So I will do that off camera and jump back once all that is locked down. But this should give us a really good idea of what our front panel is actually going to look like when all is said and done. Well, I think we are about ready to put a fork in this video and call it done. We've got our hardware all mounted up. I got everything secured down while I was off camera. And the last thing I'm going to do is just take a few more measurements with my handy cheapo calipers here. As I mentioned in the 3D modeling voiceover thingy section, one of the things I tried to capitalize on was maximizing the space around these potentiometers, especially these three, because I intend to put the labels for these controls on the knob itself. So maximizing the amount of space really helps determine, how much real estate I have to create those labels. So while I'm doing that, just a shameless plug that it is very helpful as a very small channel when folks like videos and subscribe to the channel. Obviously, the biggest thing you can do is just watch videos, especially the longer you watch, if you've made it this far especially, that's a huge help, so thank you so much for that. But doing those other things, like subscribe, bell, all the nonsense you hear all the time, there's a reason you hear it all the time. It's super helpful, and I just wanted to say I really appreciate everyone who's already done that. Okay. So here I've got 19.5 millimeters between these two. So if I split that and add a little bit of clearance, that would give me a radius of 9 millimeters. Rate and depth. That shows you can't actually see what I'm writing down, but knowing I can create a knob with a radius of 9 millimeters for both of those. And next we have our clock control. This one's a little less straightforward to measure. Looks like the closest thing is going to be this LED holder. And I'm trying to use the little slit in the knob to help find the center. I'm going to say a radius of 13 millimeters for that knob. And a lot of times I would consider knobs part of the setup in terms of the design. That said, I don't want to actually apply those until we've got everything wired up and done. So I'm going to design those knobs and have them printed up and painted while I'm, in the background while I'm working on finishing up this unit. And then we will put them on when the build is fully complete. So that said, that is the setup phase. As you can see, it's a lot of design, a lot of thinking about where you want things to be and what you want them to look like. In the next portion of this video, we will sit down and do some soldering, get all of our bins actually wired up to these controls, and our mod boards installed and put a wrap on this project and have it completely done. Now, I think I mentioned earlier in the video, but this will be for sale once I actually wrap it up. So that video should be coming out in about 2 weeks. So keep an eye out for that if you'd be interested in owning one of these. I recently found a second one of these units that I'm going to do basically do the same bins. However, I'm going to decorate it with a red and black color scheme. That way they both stay, completely unique items. But hopefully when the third part launches, I'll have both of those ready to go, and I will list those both on my website to concur with the launch of that video. So keep an eye out for that. I'll mention it in the third video as well, with the details of when those will go live, and just making sure I was able to get both of them done in a timely manner. But I think that's it for this video. So again, just a huge thank you for watching all the way through. And again, I appreciate everyone who has subscribed to the channel, and I will catch you all in the next one.